In today's lesson, we are revisiting the idea of functions. Functions is something you have been learning through Algebra 1 and Algebra 2. So first, let's look at the function definition. So this definition I've seen, worded in different ways, but it's essentially a relation, which just means a set of x values and a set of y values. We're relating x to y, in which each x pairs with exactly one y. So I like to think about what is not a function to help understand what it is, like what a function is. So if an x has to pair with exactly 1, that means if I have the x value 2, let's say it pairs with 3. The x value 2 cannot pair with another number. 2 cannot go to both 3 and 4. That would not be a function. All right, so just looking at 3 examples underneath the definition of a function. So a mapping diagram, it's kind of like an XY table, just kind of showing how x and y relate to each other. So I've got x and y. Let's say my x values are 1, 2, 3, and 4, and my y values are 4, 5, and 6. Let's say 1 pairs with 4, 2 pairs with 4, 3 pairs with 5, 4 pairs with 6. So this is a function. Yes, it is a function. So y, every x value pairs with one y value. It's fine that 2 can pair to the same 1 as long as each one has 1. All right, so looking at a graph, I'm going to draw this graph. Is this a function or not? And this is no. You might remember the vertical line test. So if we do the vertical line test, if you can draw a vertical line, and if it touches your graph twice, it means it's not a function. Because here's my x value, and then this x value matches up with 2 different y values, so it's not a function. All right, now an example where we have an equation. So y squared minus 2x equals 5. Let's solve for y. So y squared, I'm going to add 2x to the other side. So y squared equals 2x plus 5. And I'm going to square root both sides. So y equals, when you're solving equations and you have to square root, there's the plus minus the square root of 2x plus 5. Well, that means if I plug in a value for x, I'm going to have the positive and negative version of y. So 1x, 2 y's. This is not a function. All right, now reviewing function notation. I'm going to do 3 examples all using the same function. So the function is g of x equals x squared plus 8x minus 24. So example 1, function notation is find g of 6. So I've replaced x with 6. That simply means plug 6 in for x. So 6 squared plus 8 times 6 minus 24. So 36 plus 48 minus 24 is 60. All right, let's do another example. This time, let's do example 2, g of negative 4x. So I'm plugging negative 4x in for both x's. So negative 4x squared plus 8 times negative 4x minus 24. All right, so this goes to 16x squared minus 32x minus 24. And that expression cannot be simplified anymore. So that is it. All right, last example, this time a little bit more complicated. G of 5c plus 4. All right, so 5c plus 4 in for my x's. So I have got 5c plus 4 squared plus 8 times 5c plus 4 minus 24. All right, so now remember that means 5c plus 4 times 5c plus 4. So I'm going to bring that down. If you FOIL that, you'll get 25c squared plus 40c plus 16. So I did the outside and the inside all together. And then here I need to distribute. So if I bring that down, plus 40c plus 32 minus 24. All right, combine like terms. And you will get 25c squared plus 80c plus 24. All right, the last part of this lesson, we're going to look at interval notation. And we'll be converting inequalities into a new notation called interval notation. So if I have an inequality, let's say a is less than or equal to x, which is less than or equal to b. Another way to write that same thing, I'm looking from a to b, and then I have a bracket. The bracket is because of the less than or equal to. It's that or equal to. Why we have the brackets. It's including a and including b. So if we have a is less than x less than b, now I'm not including a and b. It's the interval from a to b and it's parentheses. That can be confusing because it kind of looks like an ordered pair, but it's the interval from a to b, but not including a or b. All right, so what if we have a is less than or equal to x, less than b? So it's including a, so a bracket with a, but not including b, so a parentheses with b. And you can probably guess what the last one will be. A is less than x, less than or equal to b. So it just flips. It's not including a, but it does include b. Okay, so that was bounded intervals. So unbounded intervals, if something is not bounded, that means it has no bounds, infinity. So x is greater than or equal to a. So we're looking at it includes a, but then goes up and up forever to infinity. So it's a bracket that includes a, and then it goes to infinity, and you can never touch infinity, so you'll never have a bracket with your infinity. All right, what about x is less than or equal to a? So that would be negative infinity to a. Now, same idea, except not the or equal to. So x is greater than a, and x is less than a. So same thing, just no brackets. So a to infinity, negative infinity to a. And then the last one, that is the symbol for all real numbers. All real numbers means we are going from negative infinity to positive infinity. So all real numbers, negative infinity to positive infinity. So that is interval notation of functions. That is your full lesson. Good luck.